Hi, hello everyone. So this is the second video dealing with topic 9.5, and this is specific about log equations. So we've already covered exponential equations, and now this is the flip side, which is logarithmic equations. So these are the equations where the variable or the unknown is inside the log expression. So take a look, for example, here, example 1 and 2, where I have log base 3 of x equals 5 and log base 5 of 2x plus 3 equals 2. So these are log equations because there is a variable inside the log that needs to be solved. Now, in all of these cases, and they're all done the same way, we're going to follow the 4 steps. We're going to isolate and or condense the log expression if it is condensable. So this is the, we've covered that in section 9.4, dealing with properties of logs. So once the log is isolated or condensed, we're going to convert the problem into an exponential equation. Very, very easy step. I'll show you how to do that. We'll solve third step, the remaining exponential equation. We'll get a solution here. Now this solution is only a possible solution. We have to check, and that's the fourth step, to see if the solution is acceptable. It may be acceptable, and then we say that the solution that we got is okay, or it may not be acceptable. And it is possible that if we got 2 solutions from step 3, we have to maybe remove one. Or if we only got 1 solution from step 3 and that solution is not acceptable, then we have to say there is no solution to the problem. Okay? So let's take a look at these log equations. And like I said, both cases, take a look at problem 2012. In both cases, we isolate the log. In both of these cases, the log is already isolated. There's nothing I need to do, but convert both of them to an exponential expression. How do I do that? This number here, the base of the log, is going to become the base of the other number on the right side. Meaning what? I am going to end up with x equals 3 to the power of 5. And then all I have to do is evaluate 3 to the 5th. Second case, same thing. The log is already isolated. This base becomes the base on the other side of the equation. So I'm going to end up with 2x plus 3 equals 5 to the 2nd power. Now, it's very important that you do not confuse. Normally, students will get confused and they will multiply these two numbers. They are in this relationship. So the base here becomes the base on the right side. And this number becomes the exponent. And then all I have to do is solve this simple linear equation. At the end, though, we must check to see if our solution works. In some cases, it may work, it will work. In other cases, it won't. If it doesn't, that particular solution has to be removed from the solution set. Okay, so this is basically it. Now, it is important for these problems that we remember some of the properties of logs, because we are going to see examples where the logs on the left side of the equation will not be isolated or condensed, and we need to apply the properties to do so. Okay, so let's do a few problems. I already wrote them down. These are the cases before we do the problems where we have to condense it. So let's just take a look at what we're talking about. In this case, I have 2 expressions on the left. I cannot begin the problem this way. The log on the left side of the equation must be condensed into a single log expression. So according to the properties of logs, this plus here will be turned into a multiplication of logs. So this times x minus 5. Now I have a single log expression. The 6 will go to the other side and will become the base of this number 2, 6 squared. And notice, in this case, I end up with a quadratic. So we have to remember how to solve a quadratic equation. In this case, it was possible to factor, and I got 2 possible solutions. They both need to be checked. Notice, all we have to do is replace the number inside the log. And notice that in this case, it worked. In this case, it didn't. So this has to be removed. So the only solution is the number 9. Okay, same thing for the other example, but in this case, they're in a minus property, which means that this divided by x minus 9 is equal 1. Okay, log of 10, and remember, when you do not see the base of a log, the default is 10. So log base 10, x divided by x minus 9. Now that I have a single log on the left side, this number becomes the base of this number, 10 to the first, or just 10. And then I'm going to solve this rational equation, multiplying both sides by x minus 9, and then I'm going to solve this simple linear equation. I get this answer that needs to be checked. Okay? If we do not check it, we don't know if it's right or wrong. We'll check. Well, the examples that I'm going to do now, I will check them for you. So let's begin, and I already have 4 problems that we are going to do. 2814 is the first problem. And again, these problems will just be labeled either solve or solve the log equation, just like before. I'm just going to write solve, to make things a little bit faster so that the videos are not too long. Log base 2 of x equals 7. This is a log equation because the variable is inside the log. So second step, I have to make sure that the log expression is isolated in one side of the equation. It is already. Once that step is done, all I have to do is turn this log equation into an exponential equation. How do we do that? This number goes right here as the base of the number on the right. On the left side, I am left with just x. The log disappears. I will have 2 to the 7 right here. And then we can use the calculator to evaluate 2 to the 7, which is 128. All right. We have to check. Check. To check, I will replace x with this number that we found. Okay. We can evaluate this, but this is actually 7, and I can show that to you. Okay, the calculator can handle using the simplification formula. Let's see if that works. Log base 10 of 128 divided by log base 10 of 2, and that should be 7. And there you go. Using the conversion formula, we get the number 7. Some calculators may have the actual way for us to enter the type of different bases, but if your calculator doesn't, you can use this specific formula that I've just used. Okay, so that's problem number 1. Problem number 2, 28.17. So solve again, 28.17. This log base 7, 10x minus 1 equals to 2. All right, so I looked at this. This is a log equation because the variable is inside the log. The log is already isolated on the left. So all I need to do is move this base to the right side. The log will disappear. I'm left with 10x minus 1 on the left and 7 to the power of 2. Do not confuse 7 times 2, which is 14. This is wrong. 7 squared. Now I have to solve this simple linear equation. 10x minus 1, 7 squared, 49. 7 times 7. Add 1 to both sides. And x equals 50. Divide both sides by 10. Simple enough. X equals 5. This is a possible solution. It needs to be verified. So here's the check. Log base 7. 10 and replacing x is going to be 5. Minus 1 equals 2. So log base 7. So this is 50 minus 1. Is 49 equals 2. And yes, this is sure enough. Log base 7 of 49 is 2. And you can do that on the calculator by doing the exact same thing I did before, which is log base 10 of 49 divided by log base 10 of 7. So this is exactly 2. Okay? That's the second problem. Now, the third and fourth problems that I want to do are problems that require us to condense the log before proceeding. So these two examples were simple examples, and these are more advanced. These require properties of logs. The ones I showed before on the example in our workbook. Okay, so this is example or problem 28.19. And this is the log equation. So I have log base 3 of x plus log base 3 of x plus 6 equals 3. I cannot begin the problem unless I have a single log expression. I have two. This is the first. This is the second. I can't proceed this way. They need to be condensed. Condensed, just as we did in section 9.4. So how do we do that? Well, we apply the properties of logs in reverse. So the sum of two logs is the log of the product. So this will be log base 3 x times x plus 6 equals to 3. Now I have a single log. When that happens, this number becomes the base of the number on the right. The log will disappear. Notice I have two logs here. Now I have only one. At this point, the base goes to the other side. So I am left with x plus 6 equals 3 to the third power. This is the base. This is the exponent. I already know that 3 to the third power is 27, so I have to now solve this equation, which is x squared plus 6x equals 27. 3 times 3 times 3. This is a quadratic. How do I solve a quadratic? We have to remember, so everything has to start on the left, so I have to have it equal to 0. So I'm going to subtract 27 from both sides. X squared 6x minus 27 equals 0. So notice we started with a log equation and now we have a quadratic equation. Okay, so we had a quadratic equation embedded into a log equation. So we are halfway through solving the log equation, but now we have to solve this quadratic. And we can factor this. You remember I have to find a product that is equal to minus 27 and a sum that is equal to 6. So obviously I have 9 and 3 is a possibility. And this is exactly the number that I need in order to get positive 6, right? So something with the 9 and a negative 3. The sum is this plus that is positive 6. 9 times negative 3 is negative 27. So factoring that gives me x plus 9. X minus 3 equals 0. By the 0 property, we set this to 0 and we set this to 0. So x plus 9 equals 0 means x equals negative 9. X minus 3 equals 0 means x is 3. We got two solutions. They both need to be verified. But notice right off the bat that this number, once I try to plug it in right here, I have a problem because I cannot take the log of a negative number. And you can try this on the calculator. I'll show you here real quick, right? Log negative 9. This is going to issue an error. Calculator says you cannot do that. So we know immediately that the answer negative 9 is already not allowed. This is a possibility. So we can check that one, and I think that one is going to work. Check log base 3 of 3 plus log base 3 of 3 plus 6, 9 is 3. Well, by the properties of logs, this is log of 3 times 9, 27 equal 3. Yeah, that checks, right? Because 3 to the third power is 27. So my only solution in this case is x equals 3. You must remove this, and if this is an exam, you must indicate that this is the final solution only. Okay, so this is a case where before we had to do anything, or we could do anything, we needed to condense the two logs before proceed. So let's do one more where now the property that we have to use is with the minus. And this is our last problem for this video. So log base 6, 3x minus log base 6 of x minus 2 equals 1. Hopefully I copied this thing correctly. This is problem 2821. So let's just check to make sure that this is okay. Twenty-eight, 21, 3x, x minus 2 equals, yes, that's correct. And let's do the problem. I have two expressions. I must condense it into one, but because of the minus, their property now is division. 3x, x minus 2 equals 1. Now I have a single expression on the right side, on the left side. This number will go right here as the base. The log will disappear. 3x, x minus 2 equals 6 to the 1. Well, 6 to the 1 is just 6. So how do I proceed? This is a rational equation. We are going to cross multiply. So I have 3x equals 6x minus 2. And all I have to do now is solve the simple linear equation. 3x, 6x minus 12. Notice I have to distribute the 6. I will subtract 6x on both sides, because we know we have to isolate the variable. 3x minus 6x. And we divide both sides by negative. The negative 3's cancel. I end up with x equals 4. This is my only possibility. I have to check. So I am going to replace x with 4 here and here. And this left side must equal 1. So let's see. So I have of log base 6 of 12, log base 6 of 12 minus log base 6 of 4 minus 2, which is 2. Log base 6 of 2 equals 1. Is this correct? So let's see. By the properties of logs, the minus actually has the following property. 12, this number over this number. Obviously, 12 over 2 is 6. So I have log base 6 of 6 is 1. Yes, that is correct because, right, this goes to the base. The log drops, and I have 6 equals 6 to the power of 1. And that is correct. Which means your solution is x equals 4. Okay? So this is another problem where we had to condense the logs before proceeding. Normally, the ones with the minus will end up being an easier problem to solve than the ones with the plus. Those usually tend to be quadratic equations, whereas these tend to be just linear equations. Okay, so these are the techniques that we use to solve these log equations. Two approaches. In case we have a simple log, or we have multiple log expressions here, as we saw in this example or the previous. In all cases, all we're going to do is isolate a condensed expression, convert the problem to an exponential equation, solve the remaining exponential equation, and do not forget, check if the solution is acceptable. We saw a case where one of the solutions needed to be removed. So this is important here as well.